Hello and welcome to Through the Telescope, the podcast that puts the lens on astronomy. I'm Rose Waugh and I'm an astrophysicist and science communicator.
And I'm Elliott Bruce, and I'm neither of those things, but I'll be trying to find out why we should even care about astronomy. We'll be exploring some of the big topics in the field in little manageable pieces and have some fun along the way.
So, whether you know your red giants from your red shifts, or you're not quite sure what the difference between astronomy and astrology actually is, join us as we launch ourselves into the cosmos and try not to burn up on re-entry. Through the Telescope is sponsored by Pic Astro, the astronomy and astrophotography image sharing app, dedicated to your images of the cosmos no matter what stage you are on your journey around the universe. No ads, spam, or fake accounts.
So, Ro, today we're talking about Venus, the second planet from the Sun.
This Saturday evening.
Yeah.
Coming out a bit fine this week.
Yeah.
In terms of recording.
It's been a busy week. You've had lots of corrections and things for your thesis, so you've had that to go through. Emergency recording.
But thankfully, we're talking about Venus, so it's not something that's too, alien.
It's like Earth, but really not? Is that what you mean? Or
Yeah, and just, I think we all have some level of comfort anyway with the planets.
Yes.
Because we've kind of grown up being interested in them and whatever. And they're, relatively well taught as well at university levels.
Yeah.
So it's not... I guess what I mean is you haven't decided... This week I want to talk about black holes, and I'm like,
So
I have no time, and that's out with my comfort zone.
What is an event horizon, bro? So Venus. Yeah, it's not even that far away. It's like one of our nearest neighbours. So.
Pretty close.
Yeah. Okay, so tell me the basics. How big is Venus?
Pretty much the same size as Earth.
Oh.
Really? So, I'm going to give this in miles initially because, being from the UK, we measure some distances in miles, although not all our distances.
And then when you do any form of physics, everything's in SI units, and then you forget, you just like meters, metric all the way. But when it comes to things like distances...
Yeah. I mean, we are already going off topic here, but the whole SI units thing is quite funny when you're from the UK, because I feel like, for example, and this probably is true in the US as well, I don't know, but, mass, SI unit is kilogram. Mm-hmm. Anything you care about, you are going to measure in terms of how many kilograms is it, The sun, all the way to a car, whatever. Mm-hmm. It's all kilograms. So I'm okay with that.
Yeah.
And in everyday life, we bake in grams and kilograms. I'm comfortable with the idea of a kilogram being a litre of water or, a bag of flour being like 1.5 kilograms. Yeah. It's fine. As soon as you speak to me about people...
Right, yeah.
I do not understand the concept of kilograms. Yeah. I can tell you how many pounds I am or how many pounds I am. Again, kids, they like to weigh kids and measure their height and track that on a lovely percentile. Whenever I find out how much my kid weighs in kilograms, I'm like, yeah, but what is that in real money?
Yeah.
I have no idea what kilograms are in terms of a person.
I also remember when we first met, you would think of weight in terms of pounds, and I'd be like, sorry, I only do stone and pounds. And it's like, it's an easy conversion. You just need to divide by 14.
Yeah. Yes.
Yeah. The beauty of the imperial system.
Yes, indeed.
So, imperially speaking,
the size, the radius of Venus
okay,
is 3,760
miles.
which compared to Earth, is pretty similar because Earth is 3,959.
Okay.
So they're pretty similar. If you are someone who likes to measure your planets in terms of kilometres, A, good on you, and B, the radius of Venus is about 6,050 kilometres.
Okay. And if you like to measure it in terms of Earth radii, then it's about 1.
About 1, yeah.
Right. But a little bit smaller, but pretty much the same.
Yeah.
Does that mean its mass is kind of the same as well? Or
Well, its mass is very similar because it's made of
the same
similar stuff. But just because something is the same volume, that does not mean that it's the same mass in general, because your planet could be made of a completely different thing. And then the mass would be very different.
Yes. Density.
But yes, for Venus, it's made of a similar thing, and it's a similar size, so therefore it's a very similar mass, and therefore its gravitational force is also very similar.
Yeah. So if I'm standing
Earth.
on Venus, then I'm not being ripped apart or jumping around like I'm on the moon or anything. It's pretty much...
No, yeah. I mean, you got a lot of problems, but gravity isn't one of them.
Okay. So is one of those choose temperature, given that we're closer to the sun?
Yeah. If you are on Venus, you're quite a lot closer to the sun than on Earth. Although it doesn't sound like it, because I'm going to then tell you how close is Venus to the sun. About 67 million miles. Or
Right.
again, if you like kilometres, 110-ish million kilometres. So that maybe doesn't sound that close.
Yes.
But it's pretty close.
Yeah.
About 3/4 the distance
Okay.
that we are from the sun.
Okay.
So yeah, it has a higher temperature. Its surface temperature is over 460 degrees Celsius, 860 degrees Fahrenheit for our American friends. But that's not just because it's closer.
Okay.
That's also because it has a pretty wild atmosphere.
Right, yes. We talked a little bit before, I think, did we, about, in a previous episode, about runaway greenhouse effects. And just it getting hotter and hotter and hotter. So that's the atmosphere of Venus is making the planet hotter than you would otherwise expect.
Yes.
Because it's trapping in that heat.
Yeah. So that's why Venus is actually hotter than Mercury, even though it's further away from the sun. It has a really thick atmosphere. Mercury doesn't really have an atmosphere, as we talked about a couple of episodes ago.
Yeah.
So Venus is much better at retaining any heat that it gets from the sun. And like you say, it has a runaway greenhouse effect, so it's completely out of control. If it didn't have an atmosphere, it would be about 400 degrees Celsius less.
Right, yes.
Which is about 700 Fahrenheit less than it is. So the greenhouse effect is having, a huge impact on the surface temperature.
Jeez.
Yeah.
Yeah, because I don't know if it's maybe, you forget things, you remember things, you tell yourself that you knew things that you never knew. But I'm not sure if it was only after having had a kid, and obviously all of the learning that you have when you have a kid about dinosaurs and planets.
Yeah, space.
I'm not sure if it was then that I actually knew that Venus was the hottest planet in the solar system. I think if you asked me before, I probably would have said Mercury, just because it's closer.
Yeah, and to be honest, it's a reasonable response, right? Because Mercury is so much closer to the sun that it's completely forgivable and very logical, in fact, to respond to that question with, Mercury will be the hottest. But yeah, because of this greenhouse effect, this runaway greenhouse effect, it really has increased the temperature a lot on Venus. You know,
So what is in the atmosphere?
it's pretty gross.
Okay.
It's got a lot of carbon dioxide.
Right. Okay.
It's also got quite a lot of sulfuric acid.
Lovely.
Yeah.
So they've got acid rain problems.
Yeah. It's a bit smelly. Rotten egg.
Okay.
Kind of vibes.
Right. So.
Yeah.
So I'm getting dissolved, am I, at this point?
Well, I don't know about dissolved, but the air pressure at the surface of the planet is about 90 times the surface pressure that you experience on Earth.
Okay, yeah.
So you maybe the potential rain is not your biggest issue.
So I'm very, very hot. I'm under a lot of pressure, literally.
Yes.
And also it smells.
It smells like rotten eggs.
I'm being chemically stripped away.
Yeah.
Right. I'll probably end up like a molten goo on the surface at that point. Oh.
Yeah. It's probably not the best place to visit in the solar system.
So what is the surface like? I feel like when I do hear about Venus, it's always talking about the atmosphere, which I guess when it's so thick, that's understandable. But what is the surface like? Do we know?
Well, we do now.
Okay.
For a long time, we didn't really know what the surface was like. And because it has such a really thick atmosphere, from Earth, we couldn't tell, what was going on. But, we've had probes and stuff there now. So we do know what the surface is like. It's solid.
That's a start. I can stand on it.
Yeah, you can stand on it. It's solid.
Not for very long.
It's a rocky planet, and it has a lot of volcanoes.
Okay.
Specifically, dome-like volcanoes.
So kind of like a shield volcano, like a little sort of rounded one, I guess.
Rather than a pointy one.
Yeah.
It has rifts. It has mountains. It has expansive volcanic plains, huge plateaus. So yeah, it's got a lot of geography.
Yeah, it doesn't. It sounds kind of like a hellscape, to be honest. So it's a land of volcanoes and sort of fissures and wrinkly. It just sounds sort of tectonic volcanic. Yeah. Horrific, smoggy.
Pretty much.
Yeah. No wonder it smells like rotten eggs. You get volcanoes that smell like rotten eggs, right? Because they're also emitting, like, sulfury things. Brimstone.
Yes, you do.
Well, I guess that...
Does that answer your question?
Yeah, I think so. I'm not moving there anytime soon.
No.
So, I'm guessing that means we're not really... It's not number one on our list of where to find life in the solar system.
Well, it's not... you're not going to be finding humanoid life on Venus. I think we can say that pretty confidently. But that doesn't mean there's no life.
Okay.
I mean, it's probably unlikely that there's going to be life at the surface of the planet. I mean, life on Earth proves to us time and time again that it can live in pretty crazy circumstances and environments that we previously wouldn't think there would be life. So, I suppose never say never.
Yeah. As Jeff Goldblum says, life will find a way. Indeed.
And the real answer is we just don't know if there is life anywhere, never mind on Venus. There's no conclusive evidence yet
Okay.
of life currently being on Venus or ever having existed there in the past, because, people have questioned before, maybe there could have been life on Venus before the greenhouse effect got completely run away and the planet became this really hostile environment.
Yes.
Maybe there was life before. Well, maybe there was, but we don't have any conclusive evidence that there is or ever was life there. Its surface temperature is crazy. We said it was 460 degrees Celsius, 860 Fahrenheit, which is already very extreme. And then an air pressure that's 90 times what you would have on Earth. The combination, water-based life is not going to be existing on the surface of the planet. So not just no humans, but
it's a pretty sanitary environment, shall we say.
You're going to be struggling to find anything. Of course, Venus is pretty famous these days because some scientists relatively recently suggested that, it was suggested that life in the form of a microorganism might live in the upper atmosphere of the planet where temperatures and pressures aren't so extreme.
So in the clouds?
Yeah, in the clouds. And then, relatively recently, it was September 2020, which feels like it was just yesterday, but it wasn't. A group of people, including Jane Greaves from the University of Cardiff, as well as loads of other people, a whole range of universities, like the Open University and lots of different universities, published some work that the media jumped on big time. I'm sure you remember it.
I do. And to be honest, the media loves to jump on things and maybe not necessarily distort them, maybe oversell them.
Yeah.
But it's hard to not when the answer is, when the story is, there are aliens, even if the aliens might be just like microbes. But
yes, although that wasn't the story at all.
No.
Once again, they did oversell.
And we did actually watch the press conference of by Jane Greaves, and all of the people, including her, were very, very keen to stress that they had found evidence of things that they could not attribute to anything that was not life-based, but that does not mean that there are not reasons that it might not be life-based. It might be that their understanding of things is not complete because of the different circumstances on Venus compared to Earth, but there is a possibility that it could come from life, because that's the only way we can understand it currently based on our models.
Wow.
Not the same as it's definitely aliens in it.
Yes. I'm really impressed you remembered all that.
Thank you. I do remember. I remember watching at the time, and I was like, it was so obvious that they were like, we're not saying there's life. We're really not saying. We're just saying it might be, but we can't definitively say it. It's just that it might be, and we know that.
Yeah.
Yeah.
Yeah, I felt for Jane. I really did. Jane is an absolutely fantastic person, by the way. She's absolutely wonderful.
I also remember one of the questions was, so if there is life there, then how did it get there? Did it come from Earth, or did we come from Venus?
Oh, man. Yes. So, just to clarify all of that.
To get some actual description.
For the listeners, in case anyone out there doesn't remember this,
which I think
unlikely, but
I don't know.
But
it's a long time ago.
Yeah, they found evidence of phosphenes in the atmosphere of Venus,
which are also themselves stinky.
Yes.
But I think maybe more fishy than eggy.
Oh, delightful! It's nice to have a chemist's viewpoint on this. And basically, they couldn't explain where these phosphines had come from. And they did a lot of work, and I mean a lot of work, as you have to do in science, right? To try and explain where they might have come from. And basically they concluded a few things. It could be a biosignature, which is a signature, some sort of evidence of life.
Some kind of biological process.
Specifically biological life.
Yeah.
Because, we could be up for debate about where does life begin? Does it have to be biological? Could get into some real philosophy there.
What do you mean, like aliens existing on another plane?
What about a race of robots and so on?
Oh, I see. Okay, yeah.
And if they make each other.
Yeah. Yeah.
Anyway, that could be a future episode, perhaps, if people are interested. A bit of philosophy. So it could be a biosignature, because we know that phosphines are formed in biological processes on Earth.
Mm-hmm. Including bacteria, right? There are some bacteria that...
Yeah. Or it could be, and they stressed this very heavily, as their preferred and expected reason, that it's evidence that we do not understand the chemistry and the environment of Venus's atmosphere.
Yeah.
Because they have run so many models, they've collected lots of data, they've analysed various different things, and all that understanding of the chemistry that would be happening in that environment could not explain there being phosphines present. Which you would hopefully be able to replicate, right? But because the environment of Venus and its atmosphere is so different to what we experience on Earth, as with many other things in astro, it becomes, very difficult that you can be that confident in how your understanding of, even chemistry or that we might think of as like basic and very well understood.
Yeah.
We have no experience of that environment. And so we don't actually know that our understanding of, more basic science is correct in that situation. Yeah. Basic in the sense of fundamental. As can happen in science, studies since then have not found... There have been studies since then that have not found evidence of phosphines in the atmosphere. It could be that the phosphines weren't there, and something else was picked up. It was mistaken. It wasn't analysed. There was some sort of error or something in the analysis. Or it could be that they were there and now they're not.
Right, yeah. They saw it, which I guess would suggest that then if it was life, then it got snuffed out quickly.
I don't know. I mean, I don't know how much phosphine you would have to have.
It was in a particular bit, right? They could locate it at a certain point.
Show up. I don't know what intensity you would need.
Yeah.
That's outside of my knowledge base and probably outside the knowledge base of the vast majority of people.
Was their theory kind of, if it was life, then it would have been however many millions of years ago, Venus, the surface of Venus was habitable and life evolved there, and then as the greenhouse effect took hold more and more, the surface became uninhabitable, but by that point life had got into the atmosphere. Is that kind of the idea?
Yeah, so I mean, we're talking about lots of different bits of work. Yeah, this is not one study. This is not like this one paper that's come out with all of this stuff that we're talking about. So a recent study from before this, from 2019, concluded that Venus now obviously is not habitable, but it could have had surface water and it could have been in a habitable condition for around 3 billion years.
Okay.
And
that sounds like a lot, but I guess in terms of life, that's like a reasonable amount, but not like a ridiculously large.
Yeah, it's a pretty long time, right? And it might still have been in this habitable condition until about 700 or 750 million years ago. So in the grand scheme of things, that's not really that long ago. If you're talking about 3 billion years of it being habitable. If that's correct, that's ample time for life to form and for the microbial life to then evolve to be aerial, to be within the clouds of the planet.
I think that's something that is weird to me, is like also on the Earth, that like microbes get everywhere, including the sky.
Yeah, we don't really think of microbial life as life, I think.
Yeah.
You know, we're so used to looking around us and thinking that life is the plants, the animals, the humans.
Everything macroscopic.
Yeah, and so we don't actually, come to appreciate and understand how much life is kind of everywhere on Earth.
Yeah.
And so it might sound initially pretty weird that there could be life in the clouds of Venus. But actually, it's maybe not that weird an idea, and it's not that weird a thing to propose. In that sense. You know, it's like the jury is very much out on whether life does exist on Venus or ever did exist on Venus. We just don't know the answer.
Yeah.
Certainly an interesting thing to wonder about and to think about. But we don't really... It sounds perhaps a lot more crazy than it maybe is.
Yeah. I think also when you have those 3 billion years when it could have happened, and it's a planet that's right next door, and that the Earth has managed to do it. It kind of weirdly makes it not necessarily the best candidate for life other than Earth that we have, given that we can now look at however many exoplanets, but it's the easiest, or one of the few easiest cases to actually get an idea of whether that is the case or not. Even compared to like the moon, when people talk about the moons of Jupiter or Saturn or whatever, like we can't send anything there really without waiting like ages for it to get there, and then have no idea whether it will actually get any information or not, Yeah,
we're not restricted by so many of the other things that we have with moons far out in the solar system or exoplanets that it's just very difficult to physically get to, and we rely very much on observations, just using telescopes for a lot of things. Because like you say, we can actually send probes there to do things. And hopefully learn a lot about life from that, whether that is that we ever find life or that we don't ever find any evidence of life. If we never find any evidence that life ever existed on Venus, that is insightful and that is interesting, because like you say, it seems like it was a good candidate at some point. So then why not?
Yeah. And the more information we can get on that, then the more we may potentially understand in the grand scheme of things.
Yeah.
About life. Yeah. So another thing that I've learned having a kid about space is that Venus spins in retrograde.
It does indeed. I'm impressed that it's taken you to having a kid to learn that, because I feel like that's something that comes up in horoscopes quite a lot. It's like Venus is in retrograde.
It does sound very horoscopy. It's rising.
Which of course they don't mean in that sense, but
yes,
but
it's
all the same.
Jupiter is ascending, Venus is in retrograde.
Yeah.
So you should probably have luck in your love life this month, but you might want to worry about your spending. I can't remember what the other thing is. I feel like it's always like relationships, money, and something else. Health, maybe?
Health,
I don't
probably, is it?
Yeah. You might stub your toe this month. Watch out for doors.
Okay, I hope everyone's listening to Elliott's horoscope for this month.
Well, that's only for Sagittariuses, so...
Okay, the rest of us just never get to find out.
No.
We just have to go blind into the month of April.
I mean, it's about as useful as a horoscope, so...
Yeah. So retrograde just means like backwards motion.
Okay, yeah.
So in astrology, that means, you look up at the night sky, you're looking at the stars, you're looking at the planets, and the planet is moving, backwards.
Retro.
So if you look at kind of the path that a planet makes in the night sky over time, it kind of does a weird like backwards and forwards thing instead of just going like from west to east or whichever way around it is. You can tell how bad I am with directions, but instead of just going, in one smooth motion, it kind of tracks back and forth a bit.
Yes.
Which is, how they got their name,
Mm-hmm.
because they were referred to as wandering stars.
Yeah.
In terms of Venus, the fact that it rotates in retrograde means that it rotates the opposite way about its axis to the way that it orbits.
Right, okay.
So it orbits the sun anti-clockwise, like us,
Okay.
but it rotates about its own axis clockwise.
Right. Right, so but that we go round the sun anti-clockwise and rotate anti-clockwise, I guess.
Yes.
Although I'm wondering who it is that comes along and defines which way is anti-clockwise, because if you flip the thing upside down, it would be the other way around. Convention.
Probably rich Europeans in the past.
I imagine it's that we've decided that the northern hemisphere of the Earth is the
up.
north of the solar system.
Yes.
Yeah. Nice.
Yep.
But we spin in prograde, right? Is that not the opposite of retrograde?
Yeah, most planets do.
But Venus is different.
Venus is different. Yes, because it rotates in retrograde. It rotates the wrong way, in a sense.
Okay. So
it's abnormal to spin on your axis the opposite way to the way that you're going.
Is that some like angular momentum thing again? It's always angular momentum.
Yeah.
So does that mean then the sun rises in the west and sets in the east?
Yes.
Although I don't know if you could even see
the clouds, because its atmosphere is so thick.
Nice.
But if you could see through it, then yes.
Yeah.
Which is pretty fun.
But if you were on Venus, you'd also have more issues than which way the sun's coming up.
Yeah, I think that's true.
Oh.
Yeah.
So
and it rotates pretty slowly about its axis as well. So a day on Venus takes you 243 Earth days.
That's a long day.
Yeah. And a year
Okay.
is 225 Earth days.
Wait, so a Venusian year is 243 Earth days, but a year is 225.
A
days.
day on Venus is 243 Earth days, and a year is 225 Earth days.
Right.
So it's a year is longer than its days.
So you celebrate New Year every day?
Yes.
Jeez.
Yes, you do. But I don't think I would want to be awake for an entire day on Venus.
No, I don't know how you would... I don't know how you'd be able to maintain a work schedule. And that's because it rotates slowly, going around backwards.
Yeah.
Okay, so it goes around backwards, but only just, as it were.
Yes. It's not quite, but is kind of tidally locked.
Oh, okay.
In that it pretty much one side of it faces the sun all the time.
But it does slowly move round, so the side that's tidally locked shifts over time. Is that kind of...
Yeah, that's why I say
so
it's
kind of
like
tidally locked. It's soft locked or tidally slowed. I don't know.
Yeah, so it's not like, the moon and the earth. The moon is tidally locked. We only ever see one face of the moon. We never see the dark side of the moon.
Yeah. But it's
like that, but it's not quite so synced up. But it's still, very noticeable. You still get some of the effects of it because it is, almost there, if you like.
Yeah.
So the side that's facing the sun is going to get mega hot.
Yes.
The other side is still going to be hot, but it's
but
not the same. So, yeah, you still get that kind of effect. It's just it's not quite there.
Yeah. So, this is somewhat different, but when I was looking at things about Venus for this episode, something weird that I found was if you wanted to say something was from Venus, you would say Venusian, right? That's...
yeah, one can.
Is there anything else you'd like to call it? Or just from Venus?
Yeah,
or of Venus?
I would just say it's from Venus because I don't like to struggle over the Venusian.
Yeah,
Venusian.
Yeah, whatever.
I feel like, I don't like conflict, so I'll just back out of that one.
Well, I think basically when people were starting to talk about Venus and they wanted to describe things as being Venetian, then...
There's quite a lot of different ones out there.
Yeah. People wanted to come up with a word to say it was from or of Venus, but they didn't like Venusian, which was just Venus plus Ian, because that'd be like calling it Earth Ian or whatever. So they liked to go back to some etymology, so they started off with Latin, and they were like Venus, that would be Venerian, and then somebody was like, that sounds like venereal.
Yeah.
You can't have that. That's dodgy. I'm like, right, okay. Well, let's think of the Greek version, because we love Greek things too. What about aphrodisian? And they're like, no, that sounds like an aphrodisiac. Like, there's an issue with a planet that is related to the goddess of love. So then eventually they settled on Cytherean.
Yeah.
Which I'd never heard of before.
Really?
Yeah, apparently Cytherea is the island next to where Venus appeared out of the sea.
Right.
So people started using Cytherean.
I always wondered why people went with that.
This is very, very random. But you still get a couple of people using it today. It sounds like you do.
I don't use it.
Not you personally, but you know of people that...
Yeah, well, I don't think I've ever heard it said. But I've certainly seen it written down.
Apologies to any ancient Greeks listening for my pronunciation. But
Yeah, I've definitely seen it written down quite a lot, really.
interesting.
But I don't really know how
Widespread, though.
widespread it is in kind of astrophysics rather than... Because I don't tend to read papers about Venus.
No, that's fair.
I would love to, but I just do not have time to read lots of papers that are wildly outside of my research area.
Do you read it in sci-fi then?
But yeah, I've seen it in sci-fi. I've seen it in more popular science
Okay.
stuff. It may very well be used in the, Venus astrophysics community.
I've
But
never...
I've never seen it used. I've never, seen or heard it used in kind of conferences or seminar talks where I might, come across work that's more outside my research area.
It feels like it only exists as a word to be a crossword clue.
Yeah.
It definitely feels like 3 across from Venus. You're like, Venusian doesn't fit.
Yeah. Yeah, it does.
And then you rage at the person that set the crossword at the end when you find out it was Cytherean. That's not a word.
It is though, but
But I'm just ignorant.
I've never heard it said.
It's generally how I feel when I do crosswords.
Which perhaps kind of goes to show it's not very common.
Yeah, or you don't talk to people that talk about Venus or talk about it as Cytherean.
Perhaps it's more used by the arts community.
Maybe. So, Venus was the first planet that we sent a probe to.
It was 1962 flyby.
Yeah. And I think we sent quite a few since. It's nearby, so, hopping over to other things.
Yeah.
But there are some more that have been announced relatively recently that are going to be happening supposedly in the late 2020s, maybe early 2030s. And one of my favourites, because it is, I know, your favourite thing, Ro. Veritas.
Yeah.
Obviously, truth in Latin. It's a NASA probe. Now, what does Veritas stand for? Answer on a postcard, please. It's clearly...
Venus... I don't know.
Yeah.
I don't know.
It's Venus, emissivity, radio science, INSAR, topography, and spectroscopy.
Right, so what they've done is they've taken the planet's name...
Yeah.
And then they've said, we have all these instruments on board.
Yes.
And then they've made it spell Venus.
Yeah. I think they've also been helped with...
Venus. Veritas.
Yeah, I think
it's too late on a Saturday night for this.
I think they've gone, what... It's going to be about Venus, so what words start with V? And they come up with that. So, yeah. But that's going to be launching late this decade. And...
That's very exciting.
Yeah, and I guess it takes a little bit of time to get there, but not too long, given that it's Venus.
In the grand scheme of things, not very long.
And then it's going to be looking at basically the differences in the evolution of Earth and Venus as planets, and why they are different even though they're like kind of similar, and why it is no longer habitable.
Which is a really big question that we all want to know the answer to.
Another one is Da Vinci. I don't know what this one stands for, unfortunately, but I'm guessing the V stands for Venus. Could be wrong.
I'm not a betting person, but that seems like a sensible...
But my favourite thing about Da Vinci is it's looking at the atmosphere of Venus. And part of that is it's going to drop a probe down through the atmosphere. And as it does that, it's going to be sending back messages. It's going to be taking lots of measurements, sending back all the data. And they don't necessarily plan on it remaining intact once it reaches the surface.
Yeah.
But they have a slightly sort of optimistic phrase when they say, if it does manage to reach the surface intact, then it might provide a couple of minutes of useful data before it melts.
That's pretty exciting, because a couple of minutes is actually a long time.
Especially when you got 0 minutes so
in
far.
that environment.
But yeah, it's just... I saw some other things where basically landers on Venus are not really a thing because everything melts.
Yes. There is no point in that being the aim, or at least not right now, because, the conditions are just too extreme, and to some extent it feels a bit like, what are we gaining from that? We always gain from new information and stuff, but it has to be a mission where there's a doable amount of science,
goal.
Like you have to be able to gain enough information for that to be worthwhile. And it doesn't, the conditions on Venus's surface are so extreme. But it would be very exciting if their probe managed to last any length of time on the surface. 2 minutes would be really exciting, because that's actually a pretty long time. But
you got
less than that, you're still gaining information that is helpful, and you've gained a lot of science on the way down as well. So
because I guess you can't just say, let me launch this probably multi-million dollar space probe, because hopefully it might reach the surface. If it does reach the surface, it might not crash and explode. And we might maybe just about get 2 minutes worth, maybe a bit longer, of data before it completely melts. That's a hard one to sell. Which, like you're saying about all the different kind of things that you can sort of measure, all space probes really have many different things, don't they, on them, to, I guess,
you got to maximise it.
Get the most bang from your buck, as they say. And Veritas, despite the fact that, both of us are not keen on shoving words into an acronym, all of the bits of the acronym, apart from the V, are related to a different type of...
Yeah, a different instrument that it has on board,
So...
fair play to them there.
Yeah. But with Veritas, when it's doing stuff about why Earth and Venus are different, you can come up with a better name. It doesn't need to be an acronym, Just, I don't know. If I was in charge of NASA, then they'd have a lot of problems. But, we could sort out some nice names.
Yeah, I don't like the acronyms.
No, if you do like the acronyms, then good for you, because just because other people don't like things doesn't mean you can't, but, So that's the future of studying Venus. But also, another thing that I know Venus from is the transits of Venus.
Oh, yes.
Which I don't really know why I know about them.
I would say that they're more infamous than famous.
Yeah. Yes. Captain Cook, not necessarily the most chill of guys, and he's just one part of things. But anywho, the transit of Venus is when Venus goes across the sun I was going to say the solar disk, but then I thought that sounded too pretentious. Venus goes across the sun. It's kind of like a, what's the word? Kind of like a lunar eclipse. But
I would say the solar disk, because it's not actually going across the sun. It's just crossing in front of the sun from our perspective.
yes,
It's an eclipse of a sort.
but it doesn't really eclipse it properly. So, if you know what I mean, it's too small to eclipse. So,
Yes.
yeah. So it passes in front of the sun from our viewpoint, and from, I mean, observations in like the 1600s, I think was the first time they did it, and they had to go to all different parts of the world because they only last like a couple of minutes, and and you can't guarantee weather conditions, etc., etc. So they sent a whole bunch of people out in different directions in the hope of trying to catch and measure things. And by doing this, you were able to work out the size of the solar system. You could work out the size of Venus, the distance between the sun and the Earth, and basically everything.
Yeah.
And it's just one of those sort of experiments, for want of a better word. It just sort of puts a pin in sort of our knowledge of science. You know what I mean?
Yeah.
Like before that, and also there was like no other way to know what the size of our solar system was, right?
And, 1639 or whatever it was is not actually that long ago, really.
No.
I mean...
The USA hasn't been founded yet as an independent nation.
Yeah, it's not that long ago to say that was when we had, a pretty accurate measurement of 1 AU.
Yeah.
Yeah. I mean, I don't know when you would expect humans to have that knowledge, but I think it's just sometimes it's quite enlightening looking at kind of the history of astronomy and being like, actually, like, yeah, the whole, whilst we as a species have, presumably always been, like, in some way impressed by space. And we know that humans have been interested in space for an incredibly long time. But a lot of our knowledge of it is quite recent. I mean, there are huge amounts of astronomy where our knowledge is ancient. But there's lots of it where it's really quite recent. And sometimes having that perspective is quite nice. Just realising that how much knowledge we've gained so quickly, kind of. Yeah.
So I think it's also when you have any sort of, when you've got any experience of doing physics at school, there are equations where if you don't have one thing, the equation doesn't work, right? You can't get an actual value. You just get a different equation, as it were.
Yeah, you just get a relationship.
Yeah. So until something like this, you don't have a number for whatever value, whatever parameter. And then once you do, you then all of a sudden unlock, like, all this other knowledge.
Yeah, the ability to then find out a whole bunch of other things because you have a value for something that you have, a level of confidence in.
Yeah.
Yeah.
They don't happen very often, transits of Venus. It's about every 100 years you get a pair. And
they are twos.
Yeah, and they're 8 years apart. And it's something to do with the fact that the orbit of Venus and the orbit of Earth periods are almost in a ratio that's kind of set, so that like X number of rotations of the Earth around the Sun syncs up with X many rotations of Venus. So the last one was in 2012,
Yeah.
which was the second of a pair, the other one being in 2004. And
Yeah, and I remember that.
see, I don't,
in the news.
and I'm going to need to wait until 2117 for the next one.
Yeah, I'm afraid you missed it.
So yeah. But what I also find crazy about this is people they know where you're going to be able to view. Do you know? I kind of get the idea, right? Things rotate. You know how they're all going to sync up or whatever. But it's just kind of crazy that it's like, oh yeah, you'll be able to view a perfect transit of Venus in like Egypt, Algeria, wherever. You know what I mean? Like they just know. It's the same with like solar eclipses and everything.
Weather conditions apply.
Yes.
Clouds may appear as well as disappear.
But it's just like, I just find it so crazy that we're able to like forecast that kind of thing, you know.
Mm-hmm.
But I guess also...
That's the joy of maths, though.
Yeah, and also it's a relatively simple system because we can't work out what the weather's going to be like tomorrow. But we know exactly who's going to be able to see a full solar eclipse or whatever.
Yes, well, it's a considerably simpler system than our atmosphere.
Yes.
So that's not really too surprising.
No. The other thing about Venus is that it is the third brightest celestial object from Earth after the Sun and the Moon. And you can, because it's close to the Sun, you can only see it just before dawn or just after dusk.
Yeah, that's where it gets its nickname from.
The morning star or the evening... Is it even star? Or evening star? Even star.
I think both work. We talked about this in the
Night Sky
episode. If anyone has not listened to that and is interested in hearing more about what you can spot in the night sky.
Turns out the ancient Egyptians and the ancient Greeks apparently thought that they were different. The one in the morning was not the same as the one at night.
Oh, I see. Interesting.
Which makes sense, because why would they be? But, yeah. But,
that's a pretty sensible assumption, really.
Yeah. But a weird sidebar is that actually Venus, or a mythological character that was sort of based on Venus from like an old Germanic text or whatever, inspired Tolkien to make a poem that would later expand out to be the basis of Middle-earth.
Wow.
So without Venus, we wouldn't have Hobbit, Lord of the Rings, any of it.
Huh.
Yeah.
Wow. You know, I thought I was going to leave everyone with a cool fact, but now yours is much cooler.
So go read the Silmarillion. But yeah.
Wow.
What was your cool fact?
Well, because Venus rotates so slowly, it's actually nearly spherical.
Okay.
Which maybe doesn't sound that weird, because we kind of think of planets as
Spherical.
spheres. But most planets aren't. Most objects, aren't. Because they rotate, and that squishes them or elongates them, depending on how you think about it. But Venus, so slow, it's pretty much a sphere.
I guess it's a bit like having clay on a wheel and you're trying to make a bowl or a pot or something, and then you spin it too fast and everything starts to get thrown outwards.
Yeah.
Whereas if it's nice and slow, it doesn't change its shape.
Yeah.
Well.
But it's not got anything on Tolkien, so.
Oh, fair. And with that.
Yeah, with that, we'll see you next week.
So that just about wraps things up for this episode. Please, can we encourage you to subscribe to Through the Telescope wherever you find your podcasts, and, if you like, you can leave us a nice positive review as well. It really helps the show, and it makes it easier for more people to find us.
Feel free to send us any comments, questions, or suggestions of things or people you'd like to hear about or from in future episodes. Or perhaps to put yourself forward to chat about your own astro research or experiences. As always, you can find us on Instagram at Through the Telescope Podcast, or you can find me at astrophysicist_Rose. You can also find us on Twitter at The Telescope Pod, and you can contact us by email at throughthetelescopepodcast@gmail.com.
And with that, we'd like to thank you very much for listening, and we look forward to seeing you again next time.
Bye.